Hey guys, so this is part 3. I think I'm going to continue with the menu. Yeah, I've got pretty much everything out, just patched it up a bit. That's that. Okay, if you haven't seen it yet, I recommend you go back to the previous 2 videos before you continue here, because you'll just be lost if you don't have any programming knowledge. Okay, so here with the menu function, just to continue it off from where we left off, here is case. I made separate 3 extra cases. What is this supposed to mean? If you look at our book, we'll notice that they made a case for new line, that /any new line, tab, and for open space. Meaning that this will ignore new lines, ignore tabs and spaces. What does this then mean? It means that when we're in our program, if we press enter, it won't do anything. You see, instead of going to the next line, it won't do anything. We press the space bar, okay, well, press the catch and not do that. But yeah, press, see, it won't return anything. The same is with, I think, tab. If you press tab, it's not supposed to do anything. Okay, well, in any case, I suppose it did. Well, there you have it. But yeah, add that to your code, just for your own sake. And then at the very end, you always have to have a default. Well, not always, but it's best to have a default. Default, what it does is it catches everything else you input. So if you put in value h is not part of this list, then you then define what will happen when you put in value h. Value h is part of default, which is catches everything else, and it's, I said here, incorrect value entered, please try again. So that is what I said. You can put whatever else you want there. And then I had a system pause, it paused, and then it continued. Right. So then it takes you back to the menu, as you can see here, and then you choose again. Okay, so that is our menu done. That is the easy part. Let's go back to the test. The next screen to do is display result. I will leave this up to you. It's pretty straightforward. All you have to do is we're using the same variables again. You should understand it by now. C1, C2, first voltage, second voltage, first reaction and second reaction. By now, at this point you might think it's not significant that they're using the same variable, but when we get to actually these functions, you'll see what I mean. So first, second voltage, that means that because it's already declared here at the top, here's our main body, we declared first, second, all of these. Now we can then use them when we display results. Because now we're going to make a box at the bottom called display results. I haven't even finished that in the original code, because making this video is what mattered more. And take it. So here's my original function. Display results. I'm going to copy that code. Go ahead and slap it in the bottom. So now, this is at the bottom of my coding where I'm busy defining my functions. I've now defined the display results. You have the coding, you can go ahead and look at this and you'll see it. Now, you'll notice that I have float C1, float C2, float. All of these here, right? And for each time I floated something, I said what it is I'm floating. Now, first voltage. Because it was declared, let's see, C1, C2. What's happening is when I'm floating it here, I'm actually declaring it. They're saying here that you're allowed to, when you declare this display result function, you can declare it with the same variables. Why does this matter? As I said, inside a function, these are local variables. When you declare it here, this is the same as declaring it. You're saying float C1. It's the same as saying int C1. You're declaring it while you're saying that these are your parameters. Instead of saying float parameter, int parameter. You know, that's equivalent. So you're declaring it here so that you can use it inside your function. You can't just pull random things out there unless this was a global variable, meaning that we defined it at the top here. But we don't define global variables in this program because I said we can't. So you float capacitor 1, float capacitor 2, first voltage, float pretty much everything to be safe. Yeah. float all of it. Then right at the top, when we define it, okay, let's show you, sorry, no. We define our function, pretty straightforward. You first put all the headings, and then you put all the values, connected to the values. I was still busy talking why these are significant. They say you can use the same variables. Even if I said in the very beginning of the testing, even if you put a car here, when you go to the top, because that car belongs to that box only, when you put a car here, it's not going to mean the same thing. That car will have a different value. So they were just being nice and saying that you're allowed to call it C1, as well as it meaning C1 here as well, right? They could have said call this cap, which they do with another function, call that cap1, cap2. Then that might throw you off. You're like, but I've declared, float C2 and C1 here. Secondly, because I've said float here, notice this. I had said that here, I'm floating C1, I'm floating everything, right? If I'm floating it here, that means that in my main function, I need to float it as well. So that means now we can go ahead and float it. But let me just reiterate this. Let me tell you again that because I'm declaring it here, that means I'm putting it inside this box. And when we bring the box to the front door and we bring it in the house again, we want to know that those boxes still have the same value. How can I explain it? Say for instance, look at the exchange rate. If you want to know that you still bought this in South Africa and not Zimbabwe. Say for instance this was cap 1, meaning that it was in Zimbabwe, and then when you bring it into the house, you go through an exchange rate, and now you convert it to South African rands, which is C1. In this case, we bought the product in South Africa, which was C1. Therefore, we still view it with the value of South African currency, C1. So when we bring it in the house and we look at it, it still has the same value. I don't know if this helps, I hope it does, but just know that we can now understand that those are the same thing. It has its own value inside this program, inside this function, and a different value when it's here. But ultimately, we are linking the two together, put it lightly. Okay, so like I said, float that, float everything, just float it all like a boat. Engine arm off, 413 is in. Tranquility Base here, the Eagle has landed. Float. Okay, floated that. Okay, so we floated the function, and we've defined it. Now that we've defined it, let's go ahead and copy it. Let's take it all the way to the top and declare it. Take it to the front door. Okay, now that looks pretty long. The thing that I've been waiting to tell you guys is that when you get to this point and you have something like this, this type is a float type. You're now floating it. You don't have to put C1 here, C2, all of that again. Remember, when I showed you my original function, I just said float, 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 float. Because even if you say you're declaring a function here, this only recognizes that you're declaring a function, not that you're declaring the variables. So this doesn't mean that this becomes a global variable. This is just a parameter for this function. So we declare it here. We can just say float. We can take that away. Float, right? Float. Okay. But the thing is, you have to leave float in. If you take float out, it's not going to work. So to give you return an error. So let's make that shorter. Float, 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 float. This means that we floated all the variables in this point. Why do we have to do this? Because we have to understand that this is still the same function we defined down here at the bottom. So we defined it at the bottom, we bring it to the front door. And now we brought it in the front door. Now, it becomes a part of our menu. Which part of the menu was it? The one that said display result. So for display result, I'm going to delete that quickly. Display result was option F. here. Option F. So full case F, I'm going to paste it there. And now I don't need the floats. Now I'll remove the floats. Because I still had it copied, remember? Just remove all the floats. And then I'll explain this. Okay, and that float as well. So now, we've declared it. So first of all, let's say, what happened was, we defined the function right at the very bottom. We go back to the top, we bring it to the front door, and we declare that we knocked on the door with knock knock knock. Yeah, we have a box full of floating goodies. And when we bring those floating goodies into the house, we open the box and we see, oh, okay, we've made them capacitors, made it first voltage, second voltage, and all of these options. We've said, okay, let's store in South African currency. I'm just going to go along with this analogy. If it works or it doesn't, I'm sorry. Okay, options, we don't need that, but this is everything that's inside the box, right? And we're going to show everyone, display. We're going to display them. Now that we've floated the, when we define the box, we defloated C1 already here, and we pull it here. Oh dear, I'm probably going to get pulled off my video. Anyway, display result, and then inside the box we open the box and we see that there was capacitor 1, capacitor 2, first voltage, second voltage, and all of those. But what does this mean? The thing is, why you might not understand it now is because, remember, we define it here. So after we do everything, we link everything, link that to a function, link that and that, everything to a function, we then display everything. That's why this is here. But don't forget, if you don't put a system pause, it'll just display it in less than a split second, depending on how fast your computer is. If you have a computer like a Vase, I think it takes 2 hours to start up, then well, I suppose you don't need to put a pause. Anyway, put a pause there, and then that part of the menu is done. So now all these parts are done. Now I can say for sure you've definitely got 8 marks, if you've done this correct. And then you've got part of the marks for the menu. Why I say part is because it could be the menu isn't linked here to everything, and you're not going to get the marks unless it works. Okay. Surprised I managed to do that in just over 10 minutes. Let's see. What is the very, very next thing? I'm just going to skip that. Specifications. Okay. The very next thing to do, we start with the hard stuff. Specifications for generating a capacitor. The task of this function is to generate the value of the capacitor within this range. So now we don't actually have to go and put it in microfarads. Merely when we display it at the very end, you'll say, this is in microfarads. Because otherwise we can have all these unnecessary zeros and it's going to be hard to read. Okay, using the random function. The random function is very, very, very simple. Straightforward. Let me just show you right at the bottom. Let's make some space here. Random function is like this. Ran, open close brackets, snippet. It will always be like this. All you do is, at the very beginning of the rand function, what is it saying? Nothing? And, okay. The very beginning of the rand function, we have plus. So, before the plus, we have our starting value. What is our starting value? We're going to ignore that microfarad for now. We're going to say our starting value is 2.5. What is our ending value? Ending value is 300. Done. There you have a random number between 2.5 and 300. Always be like this. If you want to make yourself more comfortable, do that. Okay, so now that is our random value. Let me show you where this is in the code. Okay, let's go to our capacitor. Capacitor right after that. This is where we generate our capacitor value. So, this was of the float type, and we generate the capacitor. Void, as in its parameters, there's no real parameters. But we float, cap value, and random number. This was a bit unnecessary because I was trying to figure things out at the time. You could even just use 1. But I'll explain it. So I just made up something called, you don't need random number, they didn't want this. What did they say? When completed, following message must be displayed. For this, they didn't actually limit you to any variable. They didn't say you could literally just create a random function and return the word random function. But I decided to call it cap value. So I said float cap value, float, why? Because it's 2.5, therefore it's a decimal place. Float cap value, and set this cap value. Okay, I'll even do it right here now for you. Just delete that. Delete that. So float cap value. So whatever we assign to this, we will allow it to have decimal places. Here is the random function I showed you just now. Calculates between 2.5 and 300. I literally take this and I assigned it to cap value. And then they said another request was to say, once it's completed, the following message must be displayed. Operation done. And what do we have here? I did that. Operation done. And then I said printf. This was just to display the cap value so I could see it was actually working. And printf the cap value with one decimal place. And then at the very end of it all, we return cap value. Why are we returning cap value and not generate capacitor? This is the name of the function. You could even say float generate capacitor, and then when you call it again generate capacitor. It doesn't really matter. When we call this function, it will return whatever we connected to this. What did we connect to this? 2.5, between 2.5 and 300. Done. Now we've declared it, right? Or sorry, we've defined it. So I'm going to go and take this function. Copy that. And this is the function I was working with you guys. Leave that there, so you know. Okay. And we go ahead and paste it here. There. That's right after my last function, display results. As I said, I'd like to do it chronologically, but because I don't want to confuse you guys, in other words, try and follow this order if you feel you're a strong learner and good in programming, follow this order like that. But because I decided to do the easy things first so you guys can score marks, this is what I did. I did display first, and now we're going to generate a capacitor. So we generate the capacitor function that inputs nothing and outputs randomly generated capacitor value. So we've now floated this, and we take that, and we now declare it. So we take it to the front door again. Where's the front door? There it is. Don't forget that we have to put a semicolon there. Let's see if I do it with the others. Yeah, we've got to put a semicolon there. It's very important, but sometimes happens. You forget to put a semicolon there. And then you make some sort of comment. Say what it is, or say what it does. Don't forget, now that I talk about the semicolon, in the menu, you must have, because we're using a do loop to keep the program going, this won't work unless there is a semicolon after this while. Now this is a very special thing you need to note of. Notice that these are round brackets, not squiggly brackets. So in other words, this is the parameter, and right after we have the parameter, we have a semicolon. Okay, now it'll run. But this program won't run, sadly, because I know that my computer just decided to do it to me now when I wanted to record. You just have to understand that I'm trying to do my best to explain it and show it to you, and hopefully getting across this way. It would have been best if I could have just run the program each time and show you, look, this is what it does, this is what it does. But alas, here we are, and we are short on time. Okay, so now what I did was I generated the capacitor, and now I know I can link it to, I did it earlier because I knew I understood it already, but we want to generate capacitor value, so we brought it to the front door. So because we floated it there and we said void, we bring it into the house and we just generate capacitor. Because it was void, remember, we don't have to put anything between brackets, we simply just call the function. And we assign it to capacitor 1 and capacitor 2. The very next thing is the total capacitance. Now, the first notice that the total capacitance, as I said earlier, doesn't have many options, so you have to be careful where you place them. They say, this is, oh, so look at that, you can get that right, so it's 8 more, done, quick. Specification for cap total. Task of this is to calculate the series equivalent capacitance, meaning that because the capacitors are in series, you calculate the parallel version of it. If the capacitors are nulls, then the equivalent capacitor calculator must be set to 0. Okay, this is a bit tricky to understand, but once you get it, it's quite simple. The variable name allowed in this function is first and second. See, remember earlier I told you that you might not see the significance in C1 and C2, but now what we're doing is we're getting something from no discrimination against them or anything. It's just the first name that came to mind. Zimbabwe. We are now bringing in an exchange function. We're bringing in a box called cap total, and it's coming from another country with a different exchange rate. First for capacitor 1, second is for capacitor 2, because these are the variable names allowed. Now they are testing it. Okay, let's go to. Oh man, nothing. Let's go to my code, and I'll show you what I need. Cap total was right after cap value. So generate the total capacitance, values, what is it inputting? Very important to note, values from the capacitor functions. So now, this was generating a random capacitor value, and we didn't have to say make a function for each capacitor. We literally just called the function twice once we made it and assigned it to capacitor 1 up here and capacitor 2. Okay, now we are making the cap total function, the total capacitance. The first thing I want you to just ignore all of that, just look here. Cap total is, if you look at this is literally, let me just pull up a notepad. This is my favorite formula to use for calculating a parallel resistors. Remember, this is a parallel calculation. So this is literally capacitor 1 times capacitor 2 as times divided by capacitor 1 plus capacitor 2. Total capacitance, right? So have a look here. I could have said...
Ты что, это записываешь?
Oh no, we're still busy making
Не хочешь работать со всеми?
total capacitance.
Да я не знаю. А ты хочешь?
So the value of first capacitor plus the second capacitor, first, second,
Что-нибудь посерьезнее?
C1, C2, as I said. Now you see the significance.
Ты думаешь, мы еще
Over
прорвемся?
here, they said we could use the same values. So this was coming from the same country. There was no exchange rate. It was a South African product. Now we are importing a box. This box is coming from Amazon, from America, or who knows where. And they're saying that the capacitor 1 is equal to first, capacitor 2 is equal to second. If you look closely at that, you'll notice there's our parallel formula. And then I said printf. Why I do this is to test. I do these printfs. They tell you they don't specify you to do this. All I want you to say is operation done. But I put this here because I want to test that my formula actually works, and that's why it displays every time I go through a menu. Like let's see, let's generate a random capacitor. This is only supposed to say operation done. But I put printf so that I can see, okay, it's actually working. Now I know I can move into the next step. Then you know you can move on. And then later, once you finish the program, you can pick this up. Okay, so anyway, there's the total capacitance. Remember that, look here, even though I've defined the function, the function, these are my parameters, capacitor 1, capacitor 2, and then this is the name of the function. But now, even though this is the name of the function, I still have to declare it if I want to use that name as a value. Why do I use that name as a value? Because let's have a look.
В наше время Можно создать приложение, завести блог или открыть
Cap
интернет-магазин.
total, first and
Но если
second.
ты диджей, надо начинать с одного трека.
They say that the only
Если он
variables
достаточно
allowed
живой,
is
достаточно
cap
честный,
total, first and second.
и если он отражает
So,
все, что сделало тебя
What I
тобой,
did was I said
откуда
cap
ты,
total, seeing as that was one of the
Кого
allowed
ты знал,
variables, and then first and second. So I
твою
say
личную
cap total,
историю,
assign that to
тогда у тебя есть шанс достучаться до всех остальных.
assign that to the parallel calculation,
И,
and
возможно,
then
это твой ключ.
return cap total. So
От всех дверей.
we calculate it, and then we return that to put that in the box, and then we take it on. But now this condition over here, they say if the capacitors are nulls, then the equivalent capacitor calculated must be set to 0. That is exactly what I did here. I said if the first capacitor 1 or, this means or, capacitor 2 is equal to, not assigned, if it's equal to 0, then the cap total must be 0. I'll show you. Oops. Yeah, that is the program. Yes, sorry. So if I don't calculate the values of capacitors as I said earlier, I just choose option B, 0. It returns 0, 0 volts. That was solve the next question. But it must return 0. So if it is 0, return, you make it, you assign it to the value of 0, and you print it, and then it'll put it in the box as 0, and it'll go to the front door. Otherwise, if it's not equal to 0, in other words, if it has gotten a value from the first option, and then here, get the value, and we go to the next step, then it will calculate. Else, otherwise, if else, print this. That's what we get. And we return it. But now, why was I able to say if it is equal to 0? Because the thing with programming is you can start a program, your variables won't be naturally assigned to a value 0, via some junk status value. So that's why we initialize. We declare variables and we initialize them. What I did was I initialized each value to 0 before doing anything. So I said float C1 is 0, C2 is 0, first volt is 0, everything. So that is why I was able to say that when I get to generating the total capacitor function, if the first capacitor or the second is equal to 0, I know that in the body, the first or the second capacitor, when we bring it into the house and we transfer it into South African rands, if that is equal to 0, then we assign it a value of 0 as they requested. Like this. That is what is requested in one of the instructions. So I think all other ways to do this, but I found this to be too right. That is done. I know it's a mouthful. If you need to, pause, take a break, and then come back. I'm going to continue going because I'm running low on speed. Okay, the very next thing was... Okay, now as I said, this doesn't have a menu function or anything we call from the menu. So we can't even put it in the generate capacitor function because they don't say call cap total. Only in calculate voltage do they say calling the cap total. So we define it over here and then we call it. Let me just see, there's something I didn't do. I'm hoping you guys are getting the gist by now, but I suppose just for the sake of what we're doing here, culture, since we defined cap total, did I put it here? No, I haven't defined it yet. Okay. So this is my original code that I wrote. Oops. That. So there. Copy. Just drop it right at the bottom, right below generate capacitor. The end of the last function. Then our next function. And then take that all the way back to the beginning. We've defined it and we take it to the front door. remember, we don't have to have the values in here, first and second. They mean nothing now. Now that we've brought it to South Africa, now it's busy being exchanged to South African rand. But we can't exchange it here. We do it inside the main body. So notice here, first cap total. Now I copy that as well. That only gets called in calculate voltage.
Would you fuck me? Are you gay?
Nope, not gay. Yeah, we only call that in the calculate voltage function, which is not even here. We bring it into South African rand, but we don't even bring it in that box. We bring it in the next box. So that is a little bit confusing, but let's go straight to the next box. So I can declare it and leave it the calculator for now. So I brought it to the front door, but he needs to come in a package. Did I bring it to the front door? Cap total. I don't think I even needed to. Did I do that? Did I? Yes. I had to bring it to the front door, otherwise it wouldn't go in. Okay. Now, calculate voltage. Process to calculate voltage goes faster. Voltage divider rule. If it's null, then you turn 0. So the same thing. If it's null, you turn 0. Once completed, must display operation done. I'll figure that. And these are the variable names allowed. Once again, first, second, and voltage supply. So now you bring in first and second, same variables, and adding voltage supply. Why are we using first and second? Because bear in mind that we are bringing that box and putting it in this box. So we want to recognize that box and this box. Therefore, we may as well use, I think, we have to use the same, well, not have to, we're using the same variables to keep things constant, otherwise you get very, very lost. Okay,
Now you're going to die.
No, okay. Here was cap total, and right after it was the capacitor voltage drop. So right at the very beginning, if first or second, again, remember I declared it as a float type, calculate voltage, and I floated. Again, I have to float the first and the second, which is capacitor 1 and capacitor 2. I have to float it again in this function. And then I do the same thing. I say if the first capacitor or the second capacitor has the value of 0, which we know is at the top, then the voltage calculated must equal to 0. You assign it the value of 0. And then you get 0 volts, which is what we've been seeing. And then you end it. Otherwise, if it already has its calculated value, then you continue and you assign it this. This is what took me the longest time. This, copy my code straight as is. I'm not going to bother really explaining it much. But this is how they wanted the voltage divider to be done. First, I had a very big disagreement with the way they did it because I need two different calculations. But this seemed to be the only one that worked based on what they gave. Yeah, this is how to calculate the voltage across any capacitor using the voltage divider. The total capacitance divided by that specific capacitor. This was very tricky. You could put first or second here, and then what I did was, okay, notice I called, there's that box I was talking about, so we bring in a box from Zimbabwe, or wherever, sorry Zimbabwe if you're offended, put it into this box, and we use its capacitor, first and second. If this was assigned C1 and C2, if we bring in that box inside of this box, we would have to use C1 and C2 because it's kind of like going from one country to the next. Think of each box as a country. So you could say these boxes are both from the same country. Otherwise, you could say it's like the variables break, they disappear outside of their function unless you call it something else. So their variables only have meaning outside of their function. Okay, anyway, we called it, this was the total equivalent capacitance divided by the value of a select capacitor. This is what I did. Eventually when I called it, where's calculate first or second voltage. First voltage, you calculate the voltage, you say C1 and C2. Why did I say C1? Because
I know so much about you.
calculate voltage. Yes. Okay, let me just follow the same method we've been doing. Let me do this. Capacitive reactance, then use that here. Come on. Can you skip the next line? Okay. Oh man, this is getting very sloppy now. Ugh, tell me that it's untied. Okay. So, this, we define our function right at the bottom. And we take it back to the frontal. Take care of that. We don't need it. You could leave it there if you want to. It doesn't make a difference. That's now being converted to another currency. Set it. And when we call it inside the body, we are calling it because we need first and second one. Can we leave it there for your step? First, capacitor 1. Second, capacitor 2. We're now calculating the voltage. That same function we're going to call twice. Once for each capacitor. First calculate the voltage across capacitor 1 and then the voltage across capacitor 2. Now this is something very interesting. Take some time to graph. Let's say okay, I already saved it. First voltage. Times that. And then just remember to remove the floats. The first and second, that can't be there anymore. This must now be C2 and then C1. Make sure it's the correct casing as well. C1. But this is where you need to pay careful attention with this voltage divider setting. Remember I said here, when I declared it, when I defined it, I divided it by, let's say divided by the selected capacitor. I just called it first, you could have called it second, but take note here. When I define the function, first is there, and second is there. So in other words, when I call this function into the main body over here, that first value is C1, and the second value is C2. So if we want to calculate the voltage across a certain component, we know we times the maximum voltage of the circuit times by that, the value, the component of the voltage we want divided by the total voltage. Okay, but in this case, we want this value capacitor, so we divide it by that value, right? This voltage. So looking here, if we're dividing by first, that means we're dividing by first. First is linked to the first value here, and when we convert it, bring it in there, first is now become C1. Therefore, if we want the value across capacitor C1, voltage C1, we put C1 first. But if we want the voltage across capacitor 2, we'll copy that, equals, there we put C2 first. So we wanted the voltage across capacitor C2. C2, this is first. First is linked to generally what would be C1. But now we're putting this in the denominator. Right over there. I'll show you again. The denominator over there, I'll flip to all of it. The denominator. And that is how I managed to calculate the the voltage across each capacitor. Right, that's done and dusted. For the rest, it's pretty much straightforward now. Cap total, cap voltage, first, second, okay, voltage supply. The only difference here, right, still did this where I said first to second. Okay, same thing. That means the same thing. If the capacitors are nulls, etc., etc. I floated the voltage supply just for safety, and then I continued on. Remember, because I want to use calc voltage, and I want to assign everything, whatever value I get to calc voltage, because they don't give me, these are the only variables I'm allowed to use. So I want to assign whatever I calculate to calc voltage, that is a variable I'm allowed to use. Then I calculate everything, assign it to this variable, and then that variable becomes a box, close it up, and then I take it down. Okay. Frequency, very easy, look at it, straightforward. This frequency is a random number. This is a random number between 300 and 100 hertz. Let's see. Now I think I can work straight from the normal code. Generate frequency. Literally just generate frequency. Remember, you have to. Int, you can call this an int, that works. You could float it if you want, there's no harm in doing that. It has no parameters, and literally just generate a random number between 300 and 1000, and we assign it to that, in the box, and we take it to our function. Right. Very next thing is calculating the reactance. This is pretty much simple as well. After this, calling the generate frequency function. You have to have everything right up until this point. This is now what we're calculating, the reactance. So 1/2 pi frequency total capacitance. So once you have your random frequency, you generate your random frequency, then go to calculating the reactance. And this calls the generate frequency box into this function. So now you can read the code and you can go over it and understand it. Now you know why I did everything I did. Everything else will make much more sense now. And the only variable names allowed here are cap, and then obviously calc reactance. That is what they don't tell you. So I said initially, if the capacitor value is null, then it must return 0 ohms. And also lastly, a very special thing they said here was, once completed, the following message must be displayed. Operation done, appearing for 1 second only. How do you do that? Easy. I just made it 1.5 seconds so you can see it for longer. You just give it a sleep function. Say sleep, and then that'll pause it for 1.5 seconds, and off you go. So let's see, what is this? This is reactance. Let's say reactance 1. I press D. Stays for 1.5 seconds, and then it goes. Shows you, go to F. F is display. Let's do E. 1.5 seconds, done. Okay, easy peasy. And then return to calculate the reactance. And look at that. Done. Okay, now all you have to do is you've made all these functions. You now have to assign each of them to a menu option. You have to assign each one to a variable in here. So you assign calculate voltage to first, add second over here, second voltage, calculate first reactance. Notice here I didn't put a system pause for the reactance. Why? Because as I just showed you, they didn't want that to stay on the screen, they wanted it to say this only 1.5 seconds. This I defined inside the function. The other thing is, if you really wanted, you could take this, because this is calculating the reactance, you could do this over here. You could put this here, but then you'd have to do it each and every time. So that's why it's easier to just put it inside of that function, and then it will print every time. But now I have to take that, I have to copy it, and the second time I calculate reactance, I have to do it again. So remember, also when I calculated this reactance, notice that it was floating, and I was only allowed to float the cap. I was only allowed to use that as my value. Because I floated it there, I declared it, I didn't have to declare it again. But because this wasn't declared, and I wanted to assign all of my values to it, I had to declare it again. Float. Okay, so then I took it to the front door, calculate reactance, float, cap, right? And then notice that cap is the value of cap that you're going to calculate the reactance for. So that you can take away there, it doesn't have to be there. Now, every time we call the calculate reactance function, because this wasn't void, see? It's float, not void. Void, no parameters. Float this parameter. So it'll float this parameter, which is that, connect it, and it'll put it inside the box. Same as with the calculate voltage. So we put it inside the box. Because of the type, we put it inside the box and done. The rest is the same as well. Put it inside the box and done. The rest you can clear up, look at the code, understand it, shouldn't take long. There's just, I think, one or two last things I want to touch on, which was this. I couldn't get it to exit properly, so I had to define an exit condition outside of the switch. At the end of the switch, this is the option. So outside of the switch, I defined an exit condition. I said if option is equal to x or it's equal to option x, meaning that lowercase x or highcase x, as they said. Where is it? Menu. Should option x be selected, the program is terminated and we need to inform by message. This is the only way I managed to exit it, because even if I use this and I said this program will now be terminated, what happens is it still goes through the loop and then it doesn't actually terminate. So I defined an extra condition that, because you see what is it breaks out of this loop, breaks out of the switch, when you choose an option, but then it just goes to the next option and it says next option. This is the end condition for the do. It says, oh well, it's not equal to option 7, so you know what, I'm gonna stay in here and I'm gonna go for another turn. So it's gonna stick his hand in the box and it's gonna go again. So that's why I defined an exit condition, which said this. I said if it's equal to that, then break again. Then that means you break out of the while loop. So this break can be used pretty much anywhere inside loops or functions. Otherwise, if in other words, if anything else, if you choose any other option, you finish in that option in the menu, then else you continue, keep going through the loop, and that's how I managed to get past that. Okay, that is the end of that. And then lastly, I think I removed it. With this, you notice here, it's in what is this? It's in the comment. SRAN time null. Why I did this is this allows for two random numbers, because even though the numbers are randomized, although it seems to be working here for some reason, what happens is the program isn't truly randomized. This was done on purpose so that you can test fire a program properly, make sure that it's working, and then you can actually truly randomize the numbers. So I said, I'll read it for you. Let's do it here. We say, there's different ways of doing it, but the easiest way is the way the book said, like this. SRAN, right? And then you have your open bracket, and then you close it. But it's not just, okay, first of all, it's just a RAN, right? Then we have what is called a seed. There was another way of doing it. You have to manually each time put in the value and it will go random from there. Otherwise, you press SRAN. What I do recommend is reading the, if you really want to understand, inside the DSL book there is an option where they show you how to roll the dice, and then they explain at the end of it how the SRAN works. But in any case, I just want to show you how to use it. Then you say time, and you open brackets. Now what time was it's very nice fact actually they put in the back in the book. They said that this time is linked to the year 1970, when time first started on the clock, something crazy like that. So in other words, it would look at the time and then it could create a random number from that time, like since that time has been, has elapsed. But instead of taking that time, we just use that time and we say null. So it's null, like nothing. And that is why in the very beginning we include this time header. Right, I am very happy. One, because I managed to now finish this video, which I'll have to upload in the morning. Number two is because I managed to get the code correct. So the good news is that this code is fully functional. The only thing I haven't done is neatened up the menu. I will do that myself. You can do it yourself as well tomorrow. And hopefully you guys understand this and you won't need the lessons offered. But like I said, I will be available. Otherwise, all the best. Cheers.